Right, hello YouTubers, and welcome back to part 5 in my DIY synthesizer basics tutorial. Now in this video I'm going to cover how we can put together a simple LFO, which obviously stands for, well, I'll say obviously, it stands for the low frequency oscillator, which is an oscillator, free running oscillator, which applications in synthesizers is mainly used as modulations, used for modulations. Now if we look at these op amps here, we have a gain, we're going to call this A, and we are going to call this part B. Now if I just flip this board over, I'm going to quickly show you a list of all the parts that you will need to build this. So you're going to need one 470k or one 1 mega ohm potentiometer, 200k resistors, 147k resistor, 122k resistor, and any one of these diodes. You can try them out, whatever you kind of have to hand really. Try and go for these type as opposed to any kind of Zener diodes. Capacitor will be something which you can put in a value of choice depending on your application of your low frequency oscillator, and you'll need either one dual or one quad op amp, and obviously some jumper cable if you're using a breadboard, or some other type of wire if you plan to take this straight to soldering. Right, now again, if we go back to part 1, we can see how I put this circuit together to give us our saw oscillator. This circuit is pretty much the same, to be honest with you. And what I've included in this one, which I should have included in the first one, was how to where to take your power rails to. If you're using the quad op amp, or should I say the dual op amp, which would be a TL072, your power pins will be pin 8 to the plus voltage, pin 4 to the minus voltage. If you're using the quad op amp, the TL074 for instance, pin 11, let me just correct that, it should be pin 4 to the plus voltage, and pin 11 to the minus voltage. So just have a look at that. Let me just clear that up for simplicity purposes. Anyhow, so firstly what we need to do is take the 47k resistor, which I'm going to call R1, and that will go from pin 1 into the non-inverting side of the op amp. Now, same as we did in the previous, or should I say in part 1, we'll have 100k resistors for voltage dividers. So this will be our plus voltage, and we'll call this R2, and we have 100k, and R3, we're going to make it 100k as well. So once we've done that, we need to take a connection from pin 5, the non-inverting side, and send that round to pin 2. Again, where I've put these circle spots, these are connection nodes. If any of these, how shall I describe them? If any of these connections, you see any of these lines going straight through, they are non-connected. just because of how I've actually just drawn this on this board here. Now we have one more resistor to put in place. That is going to come from pin 7, and we are going to take that into pin 3, and we'll call that R4, which is going to be 22K. Right, so we're pretty much there, but we're missing one component, and that is quite a very important component within this circuit, and this is our capacitor, which is C1. Now this capacitor will, depending on what size capacitor you use, that will pretty much determine the frequency range or the rate of your LFO. And once we've put all that together, what we need to do is take a potentiometer like so. It doesn't matter which way round we do this, as long as we have 2 pins. Say we have the middle pin as the input, and if we say we can take the middle pin to pin 6, or take middle pin to pin 6 and take one of these sides to pin 1, and we'll tie the other one to ground. And the reason why we're going to tie the other side to ground is so that when we turn the LFO towards ground, the LFO will stop. Otherwise we will get a continuous control voltage bump from that LFO because it hasn't actually quite stopped itself. So from this point here, pin 7, we now have a nice triangle wave output, and from pin 1 here we have a square wave output. So there we go, there's our very simple LFO. Now if we're going to look at choosing capacitors, we can pretty much go for something like an electrolytic capacitor, because they will be in the microfarad ranges, so quite high values, which will give you quite a very low frequency if we go to quite the extreme lowest frequency response. If we go for something like a ceramic capacitor, I think the smallest value, or the biggest value you can get will probably be something like a 474. The cap will be marked 474, which I think is about 0.47 microfarads, or 0.47 UF. If you're very unsure about capacitor values like I was when I first started, if you have an Android phone, there is a capacitor calculator app where you can basically download it for free off Google Play, install it, and you basically put in your three digits codes that you find on your capacitor, and it will tell you exactly the value in microfarads, nanofarads and picofarads. Very useful application there. There's also a resistor color code application as well. Again, these are also things you can kind of find online and quickly put them in live on the site, but it's quite handy to have on the phone as well. Okay, so there we go. So that's our low frequency oscillator, and basically we kind of have to think what will be your application for your LFO. If you're, say for instance, you're using this particular LFO for pulse width modulation, we probably want to keep the value between, say, we could say between about 0.47 UF microfarads to about 2.2 microfarads. And again, our range will kind of be determined by our potentiometer. We can either go for something like a 470K, or we can go for something like a 1 megaohm, which I've used pretty much on all my LFOs, 1 megaohm, which gives us quite a bit of range. Now, something very important which I kind of discovered down the line of building this synthesizer, when we tie, if we call this, we make this our potentiometer. And we'll call the wiper the middle side pin 2, and we'll say that's pin 1 and pin 3. What we will need to do is have another resistor, and I'm just going to call this R5. We'll call this resistor, and we're going to take that to pin 3. And the reason why I've taken a resistor out, again, this is one that you can kind of have to adjust to taste, is because what I found was, for some reason, this was affecting a lot of the other circuits. So I think it's something to do with the current or power draw. I'm not the most technically savvy person, so I couldn't tell you exactly what it is, but I worked out that if we put a resistor, we have this R5 resistor between here and this pin here, we can eliminate that. So we kind of want to start in, say, about 10k, and then we'll send this guy here, the middle wiper, to pin 6. So pin 1 we put on one side, and then we'll tie that to ground stroke 0 volts, so we can stop our LFO dead. Again, if we were looking at having different wave shapes, it's pretty much the same as if you look at how I built the saw core oscillator. We can build the saw core first, but then we'll have to wave shape to these other wave shapes, the square and the triangle. And we can also do a reverse saw, which I will show in another video. Anyway, I'm just going to try and keep this as brief as possible. I'm sure you don't want to hear me waffling on all day. Yeah, well, I'll see you back for part 6. Not quite sure what I'm going to cover in that video, but thank you for watching, and I hope I've been as clear as I can. If you have any questions or comments, please leave them, and subscribe and keep following these small tutorials. Please don't take every single of these values for gospel as far as the potentiometer is concerned, and the capacitors. Again, you're going to have to kind of tailor this to your circuits and to your needs. You'll kind of slowly pick it up anyway. Okay, all right, well, catch you soon, guys. Bye.